In this module, we'll move beyond simply creating HSM-backed keys and focus on running them like a disciplined service. You'll learn how to govern ownership, manage the full key lifecycle, prepare for incidents, and keep everything aligned with real-world compliance expectations. So far, you've built a strong foundation: what HSMs do, how keys behave, and how Azure's HSM options differ. You've practiced provisioning, securing, and monitoring HSMs, and using logs for operations and audits. Now we shift to long-term governance, keeping keys controlled, compliant, and trustworthy over their entire lifecycle. Deploying an HSM key is the easy part. Managing it over years is where the real work starts. Key governance defines who owns which keys, how they're used, and when they're rotated or retired. It connects operational discipline, monitoring, and incident response back to business risk, compliance requirements, and provable, auditable control. For every important key, think in terms of three distinct owners. The business owner decides why the key exists, how critical it is, and which specific uses are allowed. The technical owner ensures it's implemented correctly, integrated with systems, and kept operational. The security or compliance reviewer validates that controls, logging, and documentation match policy. Together, they prevent orphaned keys by requiring ownership metadata before any key is promoted to production. A strong key management program starts with knowing exactly what every key is and why it exists. Clear naming should reveal the application, environment, region, purpose, and even version at a glance. Combined with ownership, business purpose, data classification, and criticality, this inventory becomes your map for safe operations, quick audits, and effective incident response. HSM-backed keys only become manageable when they're well described. Tags tell you who owns the key, what it protects, which environment it runs in, and how critical or regulated the data is. That metadata then drives application mapping. Which apps, databases, identities, and APIs would break if this key is rotated, disabled, or deleted. Use consistent tags across Azure, documentation, and your CMDB, and treat missing metadata on production keys as a real operational risk. Think of keys along two dimensions: environment and criticality. First, never reuse the same key across production, staging, development, and sandboxes. Give each environment its own keys with separate names, policies, and accounts, so test mistakes can't damage production. Then classify every key as low, medium, high, or mission critical. The more sensitive the data or system, the tighter the controls, monitoring, backups, and incident response you assign to that key. Rotation and expiration policies define how long a key can safely live. Start by choosing a rotation cadence that reflects risk, data sensitivity, compliance needs, and algorithm strength. Then, define a crypto period, the approved operational lifetime for that key. Differentiate routine rotation from emergency rotation after incidents and from final retirement. Finally, track expiration dates, generate alerts, and review keys before enforcement, so applications switch cleanly and avoid outages. Design rotation cadence by risk, not habit. Highly sensitive or regulated data should have shorter crypto periods and more frequent review. Then consider algorithm and key size, traffic volume, and your threat model to decide whether annual, semi-annual, quarterly, or event-driven rotation makes sense. Align changes with application releases and maintenance windows, so cutovers are safe. When a key can't follow the standard schedule, record the exception, the rationale, and who approved it. Key rotation only works if your applications barely notice it happened. First, map how each workload references keys, IDs, versions, aliases, or configuration. Introduce the new key version, then update those references in a controlled change. Next, verify that apps can still decrypt existing data and encrypt or sign new data. Capture evidence, tickets, approvals, logs, screenshots, and keep monitoring for failed crypto calls after the cutover. Emergency rotation is your break glass response when a key might be exposed or misused. You move fast, but not blindly. Confirm the suspicion and decide how far the compromise could reach. Then contain. Restrict or temporarily disable the key and coordinate with incident response, app owners, security operations, and compliance. Before any cleanup, preserve logs, alerts, and configuration history. Finally, rotate the key, validate affected systems, and document decisions for follow-up and lessons learned. Backups for HSM-backed keys are essentially copies of your most sensitive secrets, so treat them like live keys. Start by defining backup frequency from the key's criticality, rotation schedule, and your recovery time goals. Store backup artifacts in hardened locations, with separated control over storage and operations. Limit who can backup or restore keys and apply least privilege. Finally, fully document procedures, approvals, and escalation paths, and test restores regularly. Backups only protect you if recovery actually works. Treat recovery testing as a repeatable process. Begin by planning and getting approval, with dual control so no single person can restore or activate keys alone. Then perform the restore in a safe test or approved recovery environment and validate. Did the keys work, and how long did it take? Finally, document everything in runbooks, steps, prerequisites, checks, rollback, and update them after every test. Imagine your payment signing key shows unusual signatures from an unknown identity. Treat that as a full-blown incident. First, confirm what actually happened and which systems or identities are involved. Next, contain risk quickly. Restrict access, disable or rotate keys, and isolate affected workloads. While doing that, preserve logs and telemetry so you can reconstruct events. Then meet notification obligations, assess impact, perform root cause analysis, and improve controls, so this scenario is less likely next time. HSM-backed key management only works long-term when governance is strong. Know exactly who owns each key and where it's used. Plan and rehearse rotation, backup, recovery, and incident playbooks. In the next module, we'll look at common Azure HSM mistakes and how to avoid them in real environments.